Hi, in this video we are going to implement this hasAugmentingPath method. So I'm just going to hover my mouse and create method, which is going to be a private method. It's going to return a boolean and it's going to have a parameter, the flow network, the source vertex and the think vertex. Okay. So basically on every single iteration we have to reinitialize basically the residual network. So that's why I'm going to instantiate this edge to one-dimensional array of edges. And of course we are going to have as many edges as the flow network dot get number of vertices. And we have to track this marked boolean array as well, which is going to be a one-dimensional boolean array, and again it's going to store as many booleans as the number of vertices. Okay, then we are going to create a queue as usual for the breadth-first search implementation, and we are going to store vertices, so it's going to be the queue. And I'm going to instantiate it as a linked list. I'm not sure whether you remember the breadth-first search implementation, but basically it's just going to be a standard breadth-first search. Okay, so this is the queue. I'm just going to add the start vertex, which is the source. And of course we have to set this source as marked. So the marked with the s.getID, we have to set it to true. By the way, it's not a very fancy implementation. I mean, not a very object-oriented implementation to store this marked as a reference. And basically we have, I think we have a boolean. Yeah, there's the boolean flag in the vertex, whether we have visited that given node or not. But basically I implement this flow network and fourth Fulker zone to be able to check the minimum cut as well. Maybe I'm going to refactor the code later. What's very important to get a good grasp of the implementation of the fourth Fulker zone, that we have to look for the augmenting path. What is it? It is the Edmonds-Karp implementation, so we have to make a breadth-first search. Then we have to find the mean value, basically the bottleneck in the residual graph. And we have to add the flows in the original flow network. Okay, so while the queue is not empty, and it's very important that we have to check as well that the marked on the t.getID is not equal to true. So what does it mean? That the queue is not empty and we haven't visited the think, so the node t so far. Okay, basically we just have to make a simple breadth-first search. So we have the vertex v, which is equal to the queue.remove. We just have to consider every single edge. So edge e, flow network. Oh, okay, we have to. No, I have the flow network. Okay, flow network dot get adjacencies for the vertex v. Then we get the other vertex. So the vertex w is equal to the e dot get other vertex, not the v. Okay, not the v, but the w. And if this e.get residual capacity with the vertex v is greater than 0, then we just have to check that if it is not marked. So if the w.getID is not marked, so it is equal to false, then we have to set the h2 with the w.getID to be equal to the e. We have to set it to be visited, so marked v.getID is equal to true. And then we have to add it to the queue. Okay, so basically this is a standard breadth-first search. And we just have to return with true or false, and we are able to decide it with the think.getID. Basically it's going to return after the breadth-first search that, okay, have we visited the think? Because if we have visited it, it means that there's an augmenting path from the source vertex to the target vertex, which is basically the think. So if the thing is visited, then there's a path. If it's going to return false, it means that there's no more augmenting path in the residual graph. As I said earlier, it is a bit misleading because you may get that, okay, what does it has to do with the capacity? It's not about the capacity, it's going to return a flow basically. But usually in scientific articles refer to this method as residual capacity. Okay, but what's important that we have to make a standard breadth-first search. So that's all about this implementation. I think that we are going to need two more methods. First of all, the public double get max flow return this dot value max flow, and basically we have to check that whether a given vertex with a given index is in the minimum cut or not. So I'm going to construct the Boolean method is in cut. It's going to get an index and it's going to return the marked at the index. So it's going to return a Boolean. So this is why we have to store a reference to a one-dimensional Boolean array this marked. And this is why I update it like this. Not a very, very elegant solution, not that object-oriented, but anyways, it's going to work just fine. And basically, this is what we are after. We would like to get a good grasp on the Ford-Fulkerson algorithm. And I think that this implementation is going to show you how it works in practice. Thanks for watching.